All right, so I just clamped the whole rotary table down to the mill, and I've got it secured. I just basically slapped it up here on the mill and kind of roughly centered it. I could have gotten really picky, and I could have squared this side of the table, of the rotary table, to the milling machine's table. I didn't get that picky with it because, quite frankly, odds are that I'm not going to be right at my zero mark here when I find this point. I can unclamp the table and rotate it a little bit, but that's going to move it, shift it this way, or more easily or more correctly would probably be better to just unclamp the piece, because that's again not going to move in the X or Y axis because of my locating pin, and just rotate that as necessary if I want to really get picky about having this on zero when I'm at my start of my slot. The other thing I could do is, if I'm just a little bit off, I could just take that into account. So if I'm at 5 degrees when I'm at my start of my slot, then I need to know I need to go to 95 degrees instead of 90 degrees. No big deal. I can deal with that. So I've already centered this by moving the table X and Y axis. Basically, I use my pin here, my spring-loaded pin. And what I do is, when I bring this down, I'm looking at it very closely. There's a little bit of deflection in this pin if it's not dead on. So I just look for the deflection. If it's deflecting that way, I know I need to come this way a hair. So I get the X and Y fairly close, and then I go back and I touch them up so that I know that right now I'm dead on right where I want to be. So I know that the center of rotation of this whole mess, so to speak, is directly in line with the spindle of the milling machine, give or take a couple thousandths. Again, if I really wanted to get precise with this, I would indicate it. I would actually not have this piece in here at all. I would put an indicator in here, and I would indicate this hole in reference to the mill. I'm not going to do that because I don't need to get that kind of accuracy at this point. So now I've locked my X-axis, and I'm going to use the Y-axis, and the next thing I'm going to do is I'm going to find this punch mark right here. I'm going to locate that punch mark directly underneath the point here, or the center axis of the mill. And that punch mark, the distance between the center line and the punch mark here is well, I don't have that distance because, again, I transfer punch this. So so this basically, I got to bring this out, and then I got to get myself, well, I think I'm probably going to get myself a little bit of magnification to make sure I do a good job of locating this. I can actually almost feel when I'm at the right spot. That X coordinate feels really good right there. Let me get some magnification so I can make sure the Y is pretty good. If it is, then I did a heck of a job eyeballing this thing, because I am at 0 degrees right now. All right, so looking at it under magnification, I can see that I've now got my X coordinate exactly where I want it. So I'm going to lock the table on the X-axis also. So now, if I look at my rotary table, it's set to 0 degrees. So what's going to happen is I'm going to start my slot here, and then what's going to happen is I'm going to rotate the rotary table, and as I rotate the rotary table, I'm going to plow a semicircular slot right in here, and I'm going to rotate the table until I get to the 90-degree mark, and that's when I know that's going to be the end of that slot. All right, the bolts are 5/16, but I want to give myself, obviously I don't want them too tight in the slot, so also I want to give myself a little bit of fudge factor, so I'm going to use a 3/8 inch end mill to cut these slots. Now I'm going to have to make this in, actually I can make this in one pass with this. Well, that's a 4-flute end mill, so I can't plunge with that. So I can either get a 2-flute end mill and do it with that, or what I'm going to do is I'm going to use a 5/16 inch drill bit, drill a through hole, and then plunge the 4-flute end mill in, and then plow out the slot. Now I'm setting my depth stop now so that I know when I drill the other hole that I can just come down to the stop and not worry about hitting the table. Whereas this time, since it was the first hole I was drilling, I estimated the depth of it, set the depth stop, but then at the end I made sure that I didn't just plow right through, because in case I was off on my calculations and for some reason I could have put a hole right in my table. Although I'm lined up at the slot, I probably would have missed it anyways. But. All right, so now since I already have the drill bit set up, rather than switch out to a end mill, mill the slot, and then have to switch back to the drill bit, I'm going to drill that other hole right now. The other thing I got to keep reminding myself is that it's a counterclockwise direction of the handle on this rotary table. Gives me a counterclockwise movement of the table. That seems pretty straightforward enough, but you wouldn't believe how easy it is to lose track and inadvertently go in the wrong direction. And say you're already in a slot and you're at the end of the slot, then you're going to have an oopsie, which I'd like to try and avoid. I'm also going to try and avoid changing direction on the table. That should eliminate any problems of the backlash in the worm gear of the table itself. I got my end mill in here now, and I get the sneaking suspicion that I've got a problem with my setup here because, well, for one thing, I've definitely got to bring the table up. But I also think I got a problem because what's going to happen is the spindle here is going to hit my clamp before. Yeah, that's not going to work. So way back when I first got into this hobby, and I hit the local flea market and found the guy who sold machinist stuff, and he had good deals on stuff, or so it appeared. And I think I did get some good deals there over the years. But one of the items that I bought near the beginning that caught my eye were these extensions right here. And I remember when I bought them, when I had to ask him what they were for, and he explained that this is really something. He says, you should probably sell them online. He's probably not going to get anybody who's going to want these. He had 20 bucks a piece on these. And he explained that these were extensions that would be used so you could get down into a tight place. So I just thought of it, and I said, geez, I remember I bought those things. That'd be perfect for this, you know. I could get this in there, and I could come up really close and do what I need to do, my operation. You can see I got plenty of clearance to go in there. So he had 20 bucks a piece on these, and I think I got him to take 15 for the pair. And this goes to show you just how unknowledgeable I was at the time. This one, okay, has no collets in it. So unless I find collets that fit this, this is absolutely useless to me. This one has one collet in it, which is fine and dandy if I had that one size that fits in there, which I don't. So this is what I would like to use if I had a proper size collet for it. Would have loved to have used one of these. Since I don't have that, I'm going to look for a longer end mill, which I know the longer end mill is going to give me a problem where I'm going to be side loading this end mill when I'm plowing that slot. So that's not ideal. But maybe I'll just make multiple passes instead of one big cut. Probably should do that anyways. Well, I interrupt this little project for a quick discussion about double angle collets. All right, so what I ended up finding out, there is a name, manufacturer name and part number clearly on this. This is an Ericsson, okay? And This is the one that had the collet in it. I take the collet out. It's got an Ericsson collet in it with part numbers right on it. And then after deciphering the part numbers, I was able to determine that these are what are called DA collets, or double angle collets. Now, there appears to be some indication of exactly how these run. And apparently there are different series. There's the DA 100 series, 200 series, 300 series, and then some other ones. And, you know, you'd think, oh, well, okay, 100 must be the little ones and 200. No, it doesn't work that way. In their infinite wisdom, the manufacturers settled on apparently these standards, which is a DA 300 is the small one, 200 is larger, 100 is larger still, but then you go to a DA 180, and so I got a chart. I actually looked it up online. It's a great website called Tools and Gizmos. It has a lot of no-nonsense information like this. And basically what it says is it gives me dimensions of these things. So I can actually figure, this says 100 DA right in the part numbers, and then D250 or something like that. So I think this is a DA 100. Easy enough to figure out. I just look at my chart here, and dimension D2 on a DA 100 is supposed to be 0.769, and that's spot on. Well, yeah, almost perfect. So this is a DA 100 collet. So I now know that this uses DA 100 collets. So I could go like on Fleabay. These collets individually are pretty expensive, but there are some used sets on Fleabay. There's some deals to be had if you want to shop around. But this site also basically tells you what these collets are used for, and it says, you know, that Ericsson and several other manufacturers make these, Kennametal, and that basically all of the manufacturers do not recommend these for milling operations. So if I wanted to get a drill bit down in a tight spot, then I could use one of these. But for milling, well, I guess actually you could use it for milling if you were just doing a plunge cut. But the whole point is, if you put a what is it, axial or radial load, a side load on one of these Titan collets, it can cause the collet to crack. That's what one manufacturer specifically said, and that is why they do not recommend these for milling. So I was about to see if I could find a set. Not that I was going to wait for these to come in, but I just thought, well, I'd like to have a set. And there's a set on eBay that's actually pretty cheap. It's a used set. The problem is it's a Valinite set, and the Valinite part number that they're giving doesn't correspond to any of the DA 100, 200, 300s. It has DA 30 in the part number. So I think that's going to be a DA 300, which if it is, it's the smallest one. It more than likely is the one that would fit this bar, which is unmarked. Valinite makes a bar that's almost identical to this in the MSC catalog. Boy, these damn things are expensive in Valinite. This must be, I'm assuming because it's not marked, that this is maybe a cheap knockoff. So this one I have 0 collets for. And I guess, actually, I could probably just figure out from looking at the, well, let me get this measurement. If I measure down in that throat far enough past the little beveled edge there, about 487. That would be D1, that measurement I just took. So D2 is this diameter right here. D1 was this diameter back here. This diameter back here is what's going to go down in that hole I just measured. So D2 is this. It's got to fit in here. So D2 is in the ballpark of 635. And on a DA200, D2 is 539. But that might close. I can't measure down inside there. That might close down when I get past these threads. What's the max? Well, here you go. Max tool range is going to be limited by the size of this little hole here, right? So this this max tool is going to be 420. Yeah, all right. So this uses DA200 collets. So I'm going to write that on here right now before I forget. It uses DA200 collets, and this one, as we already discussed, uses DA100 collets. And so those Valinite ones that I saw online, they were probably DA. They said 30 in the part number. I bet you they're DA300s, which are really little ones. So it's a good thing I didn't bid on those because they wouldn't fit anything I have. So this website right here, I found this page. This explains that the VDA collets numbers. So the VDA 30 for Valinite corresponds to, like, a VDA 18 is a DA 180. VDA 20 is a DA 200. But then it doesn't actually list in this page right here. It doesn't show the VDA 30, which is the collet set I found on eBay. In case you're wondering why I was contemplating it, take a look at that. There's a Valinite VDA 30-015 14-piece double-angle collet set in the box. Starting bid is only $10 plus $7 shipping. There's 8 hours and 54 minutes left. There's no bids yet. So that might be something you could steal. Get a really good deal on. Problem is I don't have the holder that would fit. I would need a DA 300 holder, because I just confirmed that. And if I go back to this page, they don't have collet sets in that size, but if you come over to here, there's a listing of, here we go, there's the VA 30. Oh, right there is the VA 30. I mean, one of those collets, the price in this catalog, all it says at the top, the prices aren't valid, so this might be old. But you can see that individually how much those collets would cost. Not going to do me any good. All right, I repositioned this clamp to the edge over here. I'm not crazy about it, but I've got it clamped with the other two. And what I'm going to do is I'm going to try and plunge cut that as far as I can. This side of the spindle right here is just going to clear this nut. So to finish this cut, I'm going to have to probably remove this clamp entirely. So I'll probably do as much as I can with the clamp on, and then take some really light cuts to finish the cut with this clamp off. I go backwards past 0 and then come back up to 0 in this direction, again because of that backlash potential. Alright, that's the maximum depth I can take there before it starts rubbing on that washer. It's funny, my thinking right there was, since there's nothing obstructing over here, why not deepen the cut right here and then mill in the opposite direction until I run out of clearance. Maybe I can get a through slot part way before I have to take this clamp off. But when I tried to plunge cut, it wouldn't go. And then it was like, well, duh, because I've got a 4-flute end mill in there. One slot down, one to go.